This video covers graphing quadratic equations, which are parabolas. This is the first of two videos. This video will focus on examples that look like y equal to ax squared minus bx plus c. The first page is a page of notes. These are steps that we want to follow when we graph. The first thing we want to do is determine if our parabola opens up or down. So parabola is a U shape. All we need to do is look at the coefficient a, whatever's in front of x squared, that a value. If a is positive, the parabola opens up. If a is negative, the parabola opens down. Next, we want to find the y-intercept. That is where the graph crosses the y-axis. Set x equal to 0 and solve for y. If x is 0, notice that if you substitute 0 for x, the first two terms will go away and we're just left with c. So the y-intercept is really equivalent to our c value, the constant term. Third step, find the x-intercepts or zeros by setting y equal to 0. Step 3 is what we have been doing this whole time. It's solving a quadratic equation. And if you set y equal to 0, you can try to factor. If the equation is not factorable, use the quadratic formula or complete the square. Sometimes the x-intercepts can be complex numbers, and if they are, then that means the parabola does not cross the x-axis. You will see this in one of the examples. Last thing we want to do is find the vertex. The vertex will be either the minimum or the maximum point, depending on how the parabola opens. We have to find the x and the y coordinate for the vertex. The x coordinate has the following formula. Once you find your x coordinate, substitute that number into your equation and solve for y, and that will give you the vertex. Let's take a look at the first example. So I have actually gone through the first steps already. Let's look at the directions first. So what we want to do is graph by finding the x and y intercepts as ordered pairs. We also want the vertex, axis of symmetry, which I will show you, and the domain and range in interval notation. So let's start. The first step is determine if your parabola opens up or down. For this example, our a value is positive 1. The parabola opens up. Our y-intercept is that c value, which in this case is 5. So we have 0, 5. That's the ordered pair. The third step, we need to find the x-intercept. So to get the x-intercept, you set y equal to 0, and we have to solve a quadratic equation just like we did in previous videos. We can factor, use the quadratic formula, or complete the square. This equation is not factorable. I'm going to use the quadratic formula. You can complete the square as well. It will give you the same answer, but I'm just going to use the quadratic formula. If you don't have the formula memorized, please have it next to you because I'm not going to write it out, the actual formula. I'm just going to plug in the values. We need to simplify. So this comes out to be 16 minus 20, which gives us negative 4, which tells us that this is actually complex since I have a negative inside the square root. So because this comes out to be a complex number, I know that if the x-intercepts are complex, then the parabola doesn't cross the x-axis. Okay, so there are, from here, I could just further simplify this a little bit. We can write 4 plus or minus 2i over 2, and we could reduce that, and we get that. So these are complex. Since we are graphing with the real in the real number plane, we can't graph complex numbers there. So these, since they're complex and not real, we will not be graphing them. So there are no real x-intercepts. Last step, find the vertex. Again, vertex is an ordered pair. I have this formula here for the x-intercept, which I will use. So to get the vertex, the x-coordinate is going to be negative b over 2a. That's our formula. So b happens to be negative 4. Negative 4 plugged into this formula becomes positive, and then 2a is just 2. So the x-coordinate is 2. To get the y-coordinate, you just take 2, substitute it into your equation. Just be careful with the parentheses and the signs. So if we calculate this correctly, we actually come out, so this is 4 minus 8 plus 5, so that's going to give us positive 1. So then our vertex as an ordered pair, I'll write it right here, is going to be x is 2, y is 1, so it's 2, 1. Okay, so I can graph the y-intercept and the vertex. I know the parabola opens up, and then we're going to get the other 3 things from our graph. So let's take a look. Here's my graph here. So I'm going to start by graphing the y-intercept, which is on the y-axis. That's going to be right here. And I have my vertex, which is at 2, 1, so that's going to be right here. Again, we can't graph the x-intercepts. Our graph, since it opens up, is going to be above the x-axis. It doesn't touch or cross the x-axis because our intercepts are complex. So here's the graph. So I have that. Now the axis of symmetry basically is an imaginary line that cuts the parabola in half, and it always goes through the vertex. So it's just going to be a vertical line that cuts your parabola in half. And we just want to write the equation of this line. So the equation of this vertical line is going to be x equals 2. It's exactly this number, the x coordinate for your vertex. And we need to write it this way, x equals 2, because it is the equation of a vertical line. I don't just want to write 2 because that doesn't mean anything. This is a line, and that's the equation of the line. So we have to write it this way. Okay, our domain and range. So domain from before is the set of all x values. So here is my x-axis. So basically, to get the domain, I just look at this x-axis here. You want to make sure you know, or you understand, that this red graph, the parabola, it has arrows here, which means the graph continues up to the right and up to the left. So if the graph continues infinitely up, to the right and left, it will cover all of these x values. So all of these x values here are covered, which means since it continues on forever, it will have a domain of all real numbers, and we need to put that in interval notation, so it looks like that. The range is the set of y values. So for the set of y values, I just focus on the y-axis. Okay, does this graph cover all of the y-axis? No, because the graph basically starts here at 1 for y, and then it goes up forever. So it doesn't contain any of the y values down here. So it's not going to be all reals. It's going to start at 1. Okay, so this is 1 for my y value. Starts at 1. 1 is included because it's part of the graph. So I use a bracket. And then it goes up to infinity, covers all of the y values. So it looks like that. So that is my range. Let's take a look at the second example. You can try to do the second example by yourself, so you could pause the video at this point and try to do this following the steps, and then come back and check your work, or you could just watch it right now. But we are following the same steps. So step 1, determine if your parabola opens up or down. Find the y-intercept. Step 1 and 2 are pretty quick. We don't have to do any work. My a value is 2, which means the parabola opens up. The y-intercept is 16. It's this constant value because, again, we substitute 0 for x, which makes the first two terms go away, and we're left with 16. And then the third step is where you got to do a little bit of work, third and fourth steps. So let's start. So this opens up again. The y-intercept is going to be 0, 16. And now I need to find the x-intercepts. So x-intercepts, you got to substitute 0 for y, right? So 0, and then we get an equation just like the ones we've been solving. Now we can see if we could factor this, because factoring would be the fastest way to go. So in this case, I could factor out 2. There's a common GCF, and it looks like this equation is factorable. So since it's factorable, I'm going to factor it. It's much faster than using the quadratic formula or completing the square. So we factor out 2. And we have one more step. All right, so from here, we set each of these factors equal to 0. The GCF, this 2, doesn't matter when we look at the x-intercepts. So we just look at these two factors, and I get my x-intercepts. I get -4, 0. And this one says x is -2, so -2, 0. So we have two x-intercepts that we could graph. And then the last thing I want to do is I want to calculate or find the vertex. The formula for the vertex. Remember, the vertex is an ordered pair. The formula is -b over 2a. That will give you the x coordinate. Then we need to substitute x into our formula, into our equation to get y. So let's find x first. So in this case, our b value is +12. So we get -12 over a value is 2. So 2 times 2 is 4. We get -3. So that's our x value. To get the y coordinate, again, -3 gets substituted into this equation and solve for y. Be careful with the signs. Parentheses, you want to make sure you put parentheses here because this will come out to be +9. And then when you calculate this correctly, that's going to give us -2. So our vertex is -3, -2. Okay, now we're ready to graph and find the other things that we need. So let's start by graphing our y-intercept. So again, that's always on the y-axis. That's going to be right here, 0, 16. Then we have our x-intercept. So there's one at -4. X-intercepts are always on the x-axis. And -2. So that's going to be right there. And then we have our vertex, -3, -2. So here's -3 and -2. So that's my parabola. I just need to make sure I draw my U shape here. Make sure you're drawing a U shape. Okay, the axis of symmetry. Again, it's a line that goes through the vertex. So this is an imaginary line. You could put it in if you want. It is a vertical line, so the equation of this line will always be whatever the x coordinate is for your vertex. So axis of symmetry, x equals -3. Our domain. Again, this graph continues to the right and to the left infinitely, so it keeps going forever. It's going to cover all of these x-axis, all the values on the x-axis, which means it's all reals. And the range starts at, so we look at the y-axis, starts at -2 and goes on to infinity. So you want to try a few examples by yourself, and the second video after this will basically do the same thing, except the equation will not look like this. It'll be in a different form.